Excellent. So today we are going to share together the concept of TinkerCad in terms of 3D and code block, and why it's very important for us as teacher to transmit those skills for our students. As a start, I would like to focus on the idea of STEAM, which is science, technology, engineering, art, and math. And here I'd like to say that some educational people consider that STEAM could be done as projects from any object that we can find around us. That's really true. If I have around me boards, plastic, cartoon, wood, metal, any kind of object, I can ask my students, let's today do, for example, a specific object to be a solution for a specific problem, or just to innovate. And in parallel, there is people who are who consider that STEAM should include technology. So here for TinkerCad, it's both. You can work on the imagination of students for creating solution for STEAM without technology and with technology, and I will share with you this experience I have with my students. But first of all, also I have to focus on the point that because you might consider, or you might have a request from your educational director, or from the owner of the school, or from any responsible at your school, that we have to work on STEAM and you have to lead somewhere. To tell you that STEAM could not be given, could not be done alone with the ICT and robotics teacher. It's impossible. Since it is STEAM, science, technology, engineering, art, and math, so languages teacher should participate, math, science, us as computer science teacher, and other teacher maybe, in order to arrive to a specific project or many projects to do at school. That's why this is very important for you to know that never take this project alone. Consider it as a sharing with the other teachers, and let's start brainstorming the ideas and the projects that you can do in order to have it. Can you see my shared screen? Can you see my shared screen? All right, thank you. So let's move to practical. I will try to divide my my training today into three main parts or sections. The first part is the technical part, how we can work on the TinkerCad 3D technically, to give you the hands-on. Second, we will move to consider a project and to see how we can do it by brainstorming ideas. And third part, it will be discovering what is code block as a section of TinkerCad. So as a first part, I will consider it now, and I will start with it now. But please do believe that TinkerCad for 3D, to give it at school in your ICT curriculum, because in the morning I had a Zoom meeting, and teachers for ICT asked me But why we as ICT teachers, we have to work on something which is not related actually to ICT. As I told you at the beginning, that STEAM does include the part of engineering, art. So that's why you have to, and math and geometry. That's why you have to consider this in your teaching. This is first. Second, you may ask yourself how many sessions I have to provide my students in order to master this platform. To tell you, as technical hands-on, no need for 1 or 2 sessions, and you will see that students will be familiar with this platform, and then you will concentrate on giving them, let's say, around, I don't know, 3, 4, 5 sessions in order to create projects. And why not? You can share those projects on your social media at school. So you have all the option for that in order to advertise or to market your work and the work of your students. So let's move to the 3D section. So I click on 3D design, and then after what I have on my screen simply is a work plan. On the right, I have tools that I will not be using all of them, just 2 or 3 as basics. And then on top, I have some tools for alignment, group, duplication, and so on. So the work plan, you can, as you can see, you can manage it using this box on the left. But of course, if you click on the button, I have a Mac computer. I don't know if on the IBM it's the same. If you press on control, you can slide your work plan and change the angle, view angle, by using the mouse. So first of all, if I go to the right section, I can see that I have a menu for basic shapes, design, vehicles, structure, hardware, electronics, fun, everyday object, and featured collection. Please do consider that once you work with your students, do not allow them to go, for example, for structure and safety and take, I don't know, this item, for example. No need, okay? You can, with your students, create something like this. So it's not an additional or an advantage for students to know how to bring a ready-made object. No sense. TinkerCad is made to explore the skills that you are going to work with your students. That's why please do not consider taking objects ready-made. So all I have to do is to concentrate on the basic shape. I'll start taking the box. I will place it on the work plan. As you can see, it's here. Once I click on the object, I have all around like arrows for rotating, and I have white boxes all around, and I have a small black triangle. So if I click on, or even if I place my mouse on the white, one of the white boxes, I have the dimension of the box. So I can click, come here, and let's say change the size. Same for the width and the height. Same for the height of the object. Let's say here I can make it 40. This black triangle is to raise my object from the work plan. So it's very important. You click once, and from here, if you type 10, for example, it's raised for 10 centimeters. Of course, here you can click to rotate. So I believe that all those features are clear for you. We don't have to lose our time for such simple manipulation. So every time I click, I have all the dots. I have all the arrows to change the properties of this box. Now I move to a second part, which is let's say creating holes in this box. So let's say I want to create a hole. Please can you close your cameras if you please? So I will take this cylinder. I will change the dimension from 20 to 10 by 10. Okay. I will turn it 90 degrees. Sorry, excuse me. This one I raise it for like 10. Okay, so I start raising this one by 15, let's say. Okay, and then I will turn it by 90 degrees. I will slide it, and as you can see, it's inside the box, but I cannot see it from the other side. It still needs more to make it larger. So let's say I make it 50 and I move it, and now you can see that I can create a hole. I can change the position. Okay, if I select both objects, I can click on align, and you will see that I can align it center from here, from here. So this is done. It's in the middle of the red box. Now, how to create the hole? Very simple. I will click on the orange cylinder. You see the properties on the right. I can click on the button hole. So now the orange cylinder has been transformed to a hole, but not yet. It makes the hole in the red box. So what I have to do as an additional function is to select the two items and then click on the group. And once you click on the group, okay, you can see that it's done. The hole is created. But before, because I have in mind a specific manipulation, what I will have to do is to copy paste. I place one aside. I select the first. I click on hole. I select both items, and then I group. I don't know if you are working in parallel with me. I don't know if you can share the screen or split the screen. Anyhow, it's recorded the session, so you can watch it in case you need some support. So now it's time to place the other orange cylinder created inside this hole. But of course, I have to reduce a little bit the dimension of this cylinder in order to I'm trying to, okay, and now I can move it, and since it's on the same elevation, you can see that it can go inside. If you want to make it, I don't, 4 by 4, amazing. So look here what I have done. So I can raise it a little bit. and then I can turn to see how the green, the orange cylinder has been inserted in the whole of the box. So I showed you the properties of the boxes, how to raise, how to create a hole, how to duplicate, how to align, and then now it's a time to see how I can duplicate objects. And believe me, all what you need are those simple manipulation, and to keep the creativity of the students in order to imagine objects, solutions for what you are giving. So I will take, let's say, another box. I will make it like 5 by 5. All right. And how, if I want to create a fence or a any kind of duplication, all I have to do is to click on the object, to click on the button duplicate. Using the arrow of the keyboard, I can move it as much as I want. And then I click and click and click and click and click. And you can see that all the objects are Mrs. Hasna, I will be sending all the recording in one shot by email to all of the participants once I finish those 4 days. Today is the last day, so expect by Sunday you will be receiving all the. All right. So here, as you can see, I've created in simple manipulation. All right. I will delete this one. I can select some of them to change. Sorry. So I will be selecting some of them. I can reduce the height, and even I can turn them. I don't know if it's not this one, the rotation. It should be. I think. Let me try. All right. So look what I have done here. So for kids, those manipulations are really, really important. I can click here on duplicate. I can place them like here. And then duplicate, duplicate, and duplicate. So I believe that it will be funny for them to explore this creativity in architecture, in design, in 3D, in geometry, and then you will expect from them objects that are really nice and amazing. So this technical part, I believe, is more than enough for your students to know. We have discovered like the duplicate, the group, the align, how to create a whole. That's it. So I will be selecting all, I will be deleting, and then let us move to the second part of this workshop, is like to create. I forget one thing, excuse me, how to create a box. I will show. No, it's a project. I will be using all the skills I have learned till now, and I will be doing 2 projects, 2 ideas for you in order to do with your students. The first is a gift box. A box, I can place anything inside, and then the cover of the box. So follow me with this manipulation. So I will take the red box. I will make it for like 40 by 40. Sorry, 40 by 40. Okay. Then I will make it also 40. I will copy the box and paste. I will change the color just for the visual. And then this blue box will be transformed to a hole in order to make the red box empty from inside. So I cannot make it right now. I have to make it a little bit smaller in order to keep the 4 sides and the bottom of the red box. So instead of keeping the size 40, I will make it, let's say, 38. 38. And the height is like 38. So here, the thickness of the box will be 2 centimeters. I will select both. I will click on align. 1 click, 2 click. Okay. I believe that the blue box have disappeared from. So I will try to make it from down. All right. As you can see, I catch it. So I will raise it for like 2 centimeters and then put it inside. I will transform it to a hole. I will select both and I click on group. And like this, you can see that I have created an empty box. It's nice, huh? So once this empty box is created, I have to create the cover. So no need to make all this manipulation again. I will click on the box. I will click on copy paste. I will make it as a height less, and I will change the dimension to 42 since the cover will be a little bit bigger than the box. I will change the color to make it a little bit funny, and then I will click on the rotate to make it, to turn it, sorry, 300, sorry, 180, I believe, no? Okay. I will raise it. I will move, it's like for 40, so I will raise it 42. I will move it. And then I can select, I can click on the align. Okay. I can, and I can close the box. And if I click here, like for 20 degrees, you can see that I can show my box opened, but of course I have to move it to hide the all right, this is it. So look at this box, it's done. And from this technique, you can create a any kind of objects that are around us in the classroom, in the school, at home, outside in the street. So you have to unleash those creativity for the students in order to create objects of that kind. Okay, so this is an idea of one project. I remind you that we are dealing now with same as 3D Max. Honestly, I didn't work with 3D Max, but I believe that maybe this is lighter. This is from Autodesk, and this is made for students. 3D Max, I believe it's more for professionals. Okay, Mrs. Amani, thank you. So now I will be moving to another idea of projects. So I remind you that the first part was to show you the skills that you have to transmit to your students in order to make working with TinkerCAD. Now we are working on showing you how from nothing we can create an object. Just what we need is to have the idea. Just we have the idea. So I will be deleting the box. And one of the ideas you can work with in the computer lab and ask for your students to imagine a solution is how to create in the computer lab a table for robotics that needs to have a border in order not to make the robot fall down on the floor. And around this table, you need to have a small table for kids to sit all around the table, just to study or to watch the robot executing the missions you asked for. So it's a nice project, and believe me, you will have many ideas that you will not be expecting. And one of the projects could be adopted by the school in order to make it real. All right. So how to proceed? Please follow the steps I'm doing. It's very interesting to have it. Same as 1, 2, 3 design. Yes, but actually, yes, if you want. Okay. But since in TinkerCAD, we have the 3 sections, which are 3D circuits for Arduino and for microbit and the code block. It would be nice to group all those together. So I'll be moving another box. I will work it manually to make it, let's say, 100 by 100. It's too big. So I will make it, let's say, 100 by 50. All right. It's okay, fine. Okay, so we consider that this is the table where the robot will work around. So first of all, I will raise it in order to create the legs later on. Okay. The same object I will copy paste. I will change in order to create the border. So here it's by 100 by 5. I will click on the rotation for 90 degrees. Okay. And I will raise it a little bit. This one is for 20. Let's make it clear. 20. This one should be, excuse me, 20. This one should be also 20. Okay. You can see that it's done. Of course, I can align it once it's I will change the color in order just to see it clear. I will duplicate. I will duplicate again, and then turn it 90 degrees for the other sides. Make the size for like I think it's 50. So here it's 50. I will move it on the border. I can do them automatically. Copy paste. And this is the table of the robot. Done. Okay, it's done. Now I will take the red table, the top. I copy paste. I will change the size for like 25. I will move it. I will change the color in order to also to visualize it. And I will make it a little bit like 18 to create this level. Copy, paste from the other side. It's a matter of imagination, as you can see. So here I have my table. I can add, for example, here, copy paste like 90 degrees to create for this side also. Okay, so here you have a table for the robot, and all around the blue table for the students to sit all around in order to see the robot working on the robot table. Of course, I can create, let's say, 5 by 5 to place the legs of the table. So I believe that there is no problem for this manipulation. Okay, so this is a table for robot and students are sitting around. So I gave you like 2 ideas of projects. Okay, we can have hundreds of ideas. Just look around, see what you have around you, and from what you can see, you can get inspired to have new objects. Okay, maybe I have a question from okay, great. So I believe that it's enough for now to have two ideas, and how to link it with the STEAM in technology. I mean, if you created a I don't know, Arduino or a microbit project, how to create it with Arduino. In case you have, and this is a must, in case you have a 3D printer, okay, so it's easy for you to have produce those. Of course, we will not produce a table for 100 centimeters, but small objects, let's say to place a LED or to place a ultrasonic sensor or a humidity sensor. So you can create small objects to fit with the electronic devices that you are working with. And then after, you can print them and combine all those together. I know that most of the schools, for the time being, they don't have 3D printers. This is what I have in mind. But hopefully, in the near future, you have, or I don't know, you already have, so you can profit from this solution in order to make this mixture between technology, Arduino, microbit, robotics, and with the 3D. I'll be moving now to, I know it's the weekend, so I'll be moving now to the third part of my presentation, which is the code block. And here, the code block is something really amazing that you will be enjoying before your students. The code block, it consists on in creating 3D designs, but using scripts, not manually as I did just now. So you can create a table, you can create a drawer, a box, any kind of objects that you can imagine, but by launching what we call a script. A script, I mean, a coding script like in Scratch, like in TinkerCad, Arduino. So as you can see here, you have all the blocks for shapes, modify, control, the math, variables, and all those are coding skills. And on your right, you have the work plan. So you cannot look here. I have my internet unstable. Hopefully you can hear me. So I was saying that I cannot take the box and place it here. It's impossible. The script will generate the design. So I will be showing you a simple example, how to start from a basic manipulation and then to move to insert, to create variables and to create looping in order to create those amazing designs. So I'll be creating, let's say, a box. I will be duplicating the box and I will be moving the box by, let's say, 25. Okay, I will select those two boxes, those two boxes, those two boxes, and then from 25, I will move to 50, 75, and 100. I will try to run the script. You see here, I run the script. And you can see that the script is generated automatically. I will not draw it manually. If I want to make it like stairs, I have to change, let's say, the Z coordinates. So I will click here and put, let's say, 20, 40, 60, and 80. I will try to make a run again and see here how my you can write on the comment if you like the code block till now, because in a while you will like it for sure once we move for the coding skills. So I cannot imagine as a teacher more than what I'm doing here is the mixture joining between coding skills and geometry skills. All right. So you can see, and this is how you have to explain it for your students. I mean, look here, the X is changing by 25, the Z is changing by 20. I cannot continue. If I want to duplicate it like 20 times, I cannot make it copy paste, copy paste, copy paste. So here students will remember the looping. So I will go for the repeat. Okay. I will delete all this. I will go to the repeat. I will place like 10 for the variables, because I have to create two variables, X and Z. I will create a variable. I will name it X. Another variable, Z. Okay. Before I'll start my program, I have to set X for 0 and Z for 0. I will place the object and I will put the variable value in the X and the Z in the Z. And then I have to change my variable X by, we said, 25, and change my variable Z by 20, I think, or 10 maybe. All right, 10. All right. Sorry. Let's try this script and see what we will have. So I can click. Maybe I will So you can see that the automation is done. Here you can rotate, you can change the color, you can combine, you can do whatever you can imagine, all by scripting. All by scripting. And I'm sure 100%, I'm sure 100%. I was just waiting to see this part as an ICT teacher. Thank you. Please send the link to all the previous. I will be sending all the previous recording with this one. Okay. So I cannot imagine, or I can imagine, how the students will be excited, like us as teachers, when you will reach this kind of automation between the coding skills and the geometry or the 3D shape. So I believe that this is very important. And in our curriculum, updated curriculum 01, we have added a chapter for 3D code block in order to enhance this skill in our curriculum. Okay. I know that on Sunday you will be starting your academic year. I'll be wishing you